Welcome back to another video, and in this video we are going to be talking about more about functions and more related to domain and the range of these functions. Now, we have approximately like 12 different basic functions that we need to learn before we talk about domain and range. And our first one, we usually call these parent functions because they are basically the most basic functions that you really need to identify a bunch of different functions with. So the identity function is our first function that we have here. Now our identity function, right, looks something like this. Draw a simple graph here. Looks like that, right? And the domain of it, right, the domain is where x is an element of all real numbers. So now this r over here, it means all real numbers, right? And the range, of course, is also the same thing, but this time we write it as y, right? Y is an element of all real numbers, right? So this is just like an equation for y equals x, right? Now, for our next function that we have is just called the squaring function. Now, this function could be like y equals x squared, right? So the graph is going to look something like this. And the domain is, of course, all real numbers, while our range is only from y is an element of only from 0 to infinity, right? So then our next function that we have is called the absolute value function. Now our absolute value function looks a bit different from all the other functions that we have. The other functions that we have is mainly just like curves, but this has a corner here, right? So it looks like a V shape, right? Just that it's because the function as it's written out is y equals the absolute value of x, right? So now let's say if x was -5, then the output will also be 5 because it's an absolute value. Now, the range for this, well, the domain first. The domain is, again, all real numbers. And our range is y is an element of from 0 to infinity. Because you're going from 0 point all the way up to infinity, right? So that's that. Then we have the square function. Square root function, I meant. Now our square root function, right, would look something like this. Y equals the square root of x. And on the graph, you only have one side of it, so it's gonna look something like this, right? Now, our domain here is x is an element of from 0 to infinity. Because we only start from the origin, which is 0, 0, and we're going towards infinity on the x-axis, positive infinity. And for our range, you may have guessed it, but it's also y is an element of 0 to positive infinity. We're almost done with all of the functions that we have here. So our next function that we have is a cubic function. Cubic function. So on the graph, it's going to look something like this. It's going to go upwards. It's going to stay in the middle for a little bit, and it's going to go back up. So as you can tell from the domain, right? Now it's going to be y equals x cubed, right? Now the domain here, x is an element of all real numbers here, right? And the range for this, of course, it's also going to be the same. X is an element of all real numbers. It's very similar to the squaring function, just that in this case, since it's a cubing function, it goes from all points, right? So as like a relationship here, since it's an odd function, right? The highest leading exponent is odd. Same thing with like y equals x, right? Y equals x, the exponent is 1, it's also odd, right? We can see that, hey, the domain is all real numbers, but then the range is also real numbers, right? Let's say if it was x squared, right? That has a positive exponent. So the range is limited to a certain value, to infinity, right? Now, let's take a look at the reciprocal function. The reciprocal function. Reciprocal function. Now, the reciprocal function is just y equals 1 over x, right? We have the reciprocal of x. Then the graph over here looks a little bit funky as well, but it looks like this. And it looks like this, right? So now our domain here is x is an element of all real numbers except for 0. Because at 0, it's a asymptote, right? It's a vertical asymptote at x equals 0. So we can just write it's all real numbers minus the set of 0, right? And now for the range, you might have also guessed it too, it also has a horizontal asymptote of 0. So y is an element of all real numbers minus the set of 0. Now I just realized a mistake that we have for our cubing function, and I wrote x for the range, which is amazing. So we're gonna switch it to y, right? That's what I realized that I did. Now, next up, we have our exponential function. Now, our exponential function will look something like this. It's gonna go up exponentially, right? So, bada bing, bada boom. There we go. So we can tell that, hey, it has a horizontal asymptote at 0, right? So this would be like y equals e to the x power, right? And our domain here, of course, it's gonna be all real numbers, right? And then our range here is y is an element of from 0 to positive infinity, because it doesn't touch a 0, so it goes all the way up to infinity. And since it's exponential, it goes up a lot faster, right? Now we have the natural log function. So now this function is a little bit different. So it could be y equals log base e of x, or it could be y equals ln of x. Now, log e of x and ln of x is the same thing, because if you switch around the bases and everything, it turns into ln of x, right? So the way how this function would look, right, is just like this. Vertical asymptote of 0 keeps on going up here, right there. So now our domain here, right, is x is an element of from 0 to positive infinity, and our range here is y is an element of all real numbers, because it keeps on going. It doesn't limit in the y direction. Now, the next one, we're going to be talking more about like trigonometric functions here. And trigonometric functions. We have two main functions that we mainly talk about here. And one of them is the sine function, right? So now remember, for this, we don't really use numbers in this case, right? We mainly use like pi, right? Pi over 2, pi, and then like 3 pi over 2, right? So this is our sine function. This is sine of x. Y equals sine of x. Our domain for this, it's just x is an element of all real numbers, right? Because it's not limited by how far you go throughout the x-axis, but it's limited by how much you go by the range, right? So for the range here, it's just that y is an element from -1 to 1. We should put brackets here, straight brackets, because they touch to these values here. Now, our second trigonometric function that we're going to be like talking about a lot is our cosine function. Draw this, right? Now, our cosine function works a little bit differently, right? So our cosine function, you see how over here it's at 0, right? Pretend that's at 0. But then over here, it's at a whole different value, right? So our y-intercept is different for these two functions. But the domain and range is indeed the same, because they are trigonometric functions, right? Unless you talk about tangent, then it becomes a little bit different. Like 1, 1, right? So that's what we talk about when we're talking about trigonometric functions. Now, this is a function that we barely use, and it's called a logistic function. Logistic function. Now, our logistic function, right, it's a little bit different, but it's not entirely too different from what we've seen all along. So it looks something like this, right? So how we write this is y equals 1 over 1 plus e to the negative x. Now you can go to Desmos, right, and just like plug this in and see how it looks throughout the whole thing. But we're just here for the basics. So the domain is x is an element of R, right? And our range, in this case, is from 0 to 1, right? So y is an element of 0 to 1. And lastly, we have the greatest integer function. Integer function. Spelled something wrong there. But our greatest integer function, it's like steps, right? So it goes from here, 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 there, there. Okay, so the point is it's on steps, right? And on each of these individual steps, the left bound is closed circle, but then the right bound is an open circle. So it makes more sense that way. Now, the way how we write this is y equals the brackets of x. That's how we write it. Now the domain is x is an element of R, and the range is just y is an element of z, right? So now the thing with z is that it's telling you, hey, it's every step that we have. So like 1, 2, 3, 4, 5, right? So that's how it works basically. Now, the whole entire point about these different functions that I just told you about, all 12 of them, is that mainly because you can find the domain and range of any type of function, which you have to do because of the Regents examinations. And let's say you're trying to find the interval, right? You're also trying to find the domain and the range of whatever function that you have, right? So whenever you approach these questions, make sure which one are you finding. Are you finding the x-axis or are you finding the y-axis, right? Are you finding the domain or are you finding the range? And based off all of these things, concepts, right? Then you can figure things out by yourselves, right? So for a sine function, right? Of course, the domain is from negative infinity to positive infinity, right? But the range is going to be a little bit different. The range is going to be from like -1 to like +1, unless whatever else changes in it, right? So use all of what you have there, and it's going to be a lot easier to figure out these functions. So yeah, if you want more practice on like domain and range, make sure that you do that because that will help you deal with a lot of these problems. And including with domain and range, right? There's a lot of symbols for it. So sometimes teachers they only want you to put some kind of interval on there. And sometimes some people they just want you just to put the full entire set. So make sure you confirm that and make sure you keep on practicing. And I'll see you guys in the next video.